Operation video for PM 360A Ultrasonic Precision Thickness Gauge. Main unit, charger, USB flash drive and hex key wrench. Probe optional, probe cable optional. Firstly, connect the probe to the device. Connect the probe interface and tighten it. The other end connects to the device's port, the third port from the left. There is a triangular icon next to the device port. For a single crystal probe with a single crystal cable, it should be connected to this port. Once connected, turn on the device. After powering on, you will enter the main interface. Before testing, first confirm whether the probe type matches the model. Go into the menu, then enter the measure. You'll see the probe type is V15. It's correct, so no need to change. Thick mode, EE mode is for general thickness measurement. PE mode is for measuring thicker workpieces. Thin E mode is for coating measurement. Thin mode is for thin workpieces. Units, you can switch between millimeters, micrometers, and inches. Resolution can be adjusted up to 4 decimal places. We'll first set it to EE mode for measuring suitable workpieces. This is the sampling frequency. Higher frequency results in slower detection speed. Generally, set it to 5 Hz. After setting, return to the measurement screen. We can now perform calibration using this standard test block. EE measurement. Short press the power button, select the first option, then press the calibration button. Apply coolant, place the probe vertically on the calibration block, and a beep will sound indicating calibration is complete. Press confirm to finish. Let's test with this feeler gauge as an example. This is 1 millimeter thick. Thickness 0.75 millimeter. Thickness 0.4 millimeter. Thickness 0.25 millimeter. For measuring thin workpieces like 0.15 millimeter and below, it is recommended to select thin mode. Let's adjust the settings now. Thin mode is designed for thin workpieces. Thickness 0.15 millimeter. Parameter storage function. After testing this common workpiece, let's discuss how to save data. We have already set the probe parameters, including product parameters. Okay, let's save them. Go to the material. Navigate to the parameter list and select New. Press New button. For example, let's name it 2 and press Save. This step only to create the name. Next, return to the name 2. Press the button to move on screen cursor to the right side, and choose Save and press Confirm button to storage current parameters to the name 2. Next time you need to load these parameters, go to Menu, enter Material, find the saved parameters. Select Load on the right and press Confirm button. After setting, press the left button to return to the list. Sound velocity reversal method. If we don't know the sound velocity for different workpiece materials, how do we calibrate? Here is an aluminum workpiece. Let's find its calibration. First, use calipers to measure its thickness, approximately 1.8 millimeter. Then select the second option on the device. Adjust the thickness to 1.8 millimeter and begin calibration. Apply coolant and place the probe vertically on the calibration block. A beep will sound indicating calibration is complete. Press Confirm. The device is currently in thin mode. If you want to measure a generally thicker workpiece, you can switch to EE mode and proceed with the measurement. Let's measure this thicker section here. This demonstrates sound velocity, calibration for workpieces of different materials. Input the actual thickness of the workpiece to inversely calculate the sound velocity for that product. Coating measurement operation. Next, let's test this coating. We'll use 49.5 m and 102 m as examples. First, adjust to 49.5 m, which is 0.05 millimeter. Then return to Settings and change the thick mode to Thin E. If millimeters are not easy to read, you can switch to micrometers. Now in M micrometers. First, perform calibration. Since this is coding mode, the measurement range is not as wide. Press the left button to reduce the range, then proceed with measurement. So, press the calibration button and calibrate. Now you can see the sound velocity for this plastic sheet. The actual thickness of the plastic is about 49.5 m. Let's measure the 102 M1. Thank you for watching.